Right, hello and welcome. I am Steve Jorson with Northeast Metro Climate Action. We are a volunteer-run community organization located in the northeast corner of the Twin Cities. Our mission is to raise awareness about the climate crisis in our communities and work with local and state elected leaders to promote climate policy, as well as we do climate activities in the community where available. So our outreach events like this one, we've been doing these for a couple of years now. The last 14, 15 months have been via Zoom, obviously. And we're hoping to be back in person in September for our next outreach event. For the rest of the summer, we will be participating in community events like White Bear Market Fest on August 5th, Heritage Days Parade for Vadnais Heights on August 15th, and I believe Slice of Shoreview as well. I don't have the date for that. But there we'll also meet with the community and talk about climate action in our communities, because talking about climate change is one of the most important things we can all do to raise awareness about climate change. Tonight's event is a watch party for Project Drawdown, and they've posted 6 unit videos on climate solutions. They call it Climate Solutions 101. And we're going to watch units 3, 4, and 6 tonight in looking at carbon emission sources. In the first one, it's a 23-minute video. Then we'll have some, if there are questions after that, we can, if you want to ask a question, go ahead and either write your question in the chat or just write in the chat, I have a question, and we will call on you to, if you have any questions or have anything to discuss after that. The second unit video is called Sinks and Society, I think. And then the last video will be taking action. How do we get all this taken care of? So we can go ahead, and I'm going to share my screen. Before we click on the first video, are there any questions or any other housekeeping things that we need to address before we go to the first video? All right, and I'm going to hit share screen, share sound, and I'm going to hit play. Centered, okay. Okay, yes.
Okay, so now we're going to talk about reducing the sources of greenhouse gas pollution. I already told you that this is going to be key to addressing climate change. We're going to stop the problem before it even gets into the atmosphere. And that's the way we need to begin. So we're going to zoom in and look at all the different contributors to the sources of greenhouse gas pollution and how we can bring these things down to zero and stop the problem in its tracks. Well, what are the sources of this greenhouse gas pollution to begin with? Well, you've heard of a few of them, but some of them are going to be kind of surprising. One of the places we should begin is the biggest emitting sector of greenhouse gases, which is making electricity. It turns out that burning coal in a power plant or natural gas creates carbon dioxide, and that is a big contributor to climate change. Overall, across the world, it's about 1/4 of the problem. In some countries it's bigger, in some countries it's smaller, but the globe as a whole is 25%. The next biggest source of greenhouse gases often surprises people, and it's 24%, is food. It turns out that growing food and agriculture and the land use associated with all of that together is about 24% of our emissions. Isn't it weird that electricity and food are about equal and together are half of climate change? We hear a lot more about the electricity space, though, than we do the food space. It turns out they're about equally important. Then we switch over to industry, kind of making all the stuff in the world. We'll go through a lot of those different things, but making steel and cements and plastics and other things, as well as managing waste, is what's happening here, and that's 21% of the problem. Then we've got transportation, moving us and our goods around the planet, Whether it's a car, a truck, a plane, a ship, and whatever, that's about 14% of the problem. Then we go to buildings. Buildings cause about 6% of climate change. But to be fair, buildings also are using a lot of the electricity. They're responsible for some of the industrial emissions to make the components of buildings. And of course, transportation takes us from building to building. So buildings directly, from their furnaces, their hot water heaters, boilers, and air conditioners, emit greenhouse gases, but they have a big effect on a lot of the other sectors. So how we build buildings and what we do with buildings and the design of cities is crucial throughout all of those wedges of our pie chart. Then we've got the remaining 10%. That's a lot of different things, but it's actually dominated by the energy industry. It's going to be responsible for things like fugitive emissions, the kind of leaks of methane and natural gas that aren't intentional, or when they flare off natural gas in an oil well, or the emissions when we refine crude oil into things we use like diesel fuel, gasoline, and so on. So energy industry and a few other things show up in that last 10%. But look at the first 5. It's kind of amazing that only 5 things, electricity, food, industry, transportation, and buildings, cause 90% of climate change. Well, heck, that's just one hand. We can solve 90% of the problems with just this. That's pretty good. So let's go through each of these sectors and kind of see what can we do to reduce these emissions and eventually bring them down to zero. So we're going to look at each sector, and then we're going to dive into particular solutions, and we're going to show you how at Project Drawdown we've tried to estimate the size of these different solutions and which ones might work best. So let's start with electricity. Electricity, again, produces about 1/4 of the world's greenhouse gases. And the production of electricity burning fossil fuels, especially coal and natural gas, causes those emissions. But we can also look at how electricity is used. Most of the world's electricity is used in buildings for lighting and air conditioning, heating, refrigeration, all those kinds of things. And about the other half or so is used in industry, making stuff, big industrial, big machine processes. The rest is about 2%, that's used in food and transportation and everything else. So buildings and industry are the big users. Well, let's make this kind of real. Burning coal and natural gas in a power plant is what produces these emissions, and that's what makes electricity, and sometimes we use the heat in a power plant for something else as well. We take that electricity, we put it in buildings, industry, and everywhere else. And the kind of electricity we make is associated with the electricity that's in the grid, but also the greenhouse gases we put in the atmosphere. For example, burning coal releases about 2 pounds of CO2 for every kilowatt hour of electricity we use. Natural gas is a little less. It's more like 1.2 pounds of CO2 for every kilowatt hour we produce. Then we have solar, wind, nuclear, and other forms of making electricity that don't produce any CO2. So this is a big difference between the fossil fuels electricity and the non-fossil fuel electricity. It's a huge, huge difference. Now let's make this real. A kilowatt hour is what we use to measure electricity consumption. A kilowatt hour is like using 1,000 watts for 1 hour. A hairdryer uses about 1,000 watts. So if you turned on a hairdryer and left it there for an hour, that's 1 kilowatt hour of electrical use. Pretty simple. Well, the average American home uses 1,000 kilowatt hours every month, on average. Some use more, some use less, for all the different things we use electricity for. Well, if we do the math, 1,000 kilowatt hours on America's electrical grids, which releases on average about 1.4 pounds of CO2 for every kilowatt hour, that means an average American home is responsible for over 16,000 pounds of CO2 pollution, or over 8 tons. That's incredible. How would we reduce that? Well, we already kind of know, don't we? We can have energy efficiency. We could reduce the use of electricity. No matter how the electricity is made, we could probably cut it in half with better lighting, better air conditioners, better appliances, and so on. But then we can also switch the way we make electricity to things like renewables that don't emit any CO2 at all. So that 1-2 punch of efficiency and transforming to renewables is key here. While Drawdown, we looked at those solutions not at your home level, but at the larger economy level, at the whole planet. And we looked at a whole bunch of solutions that could enhance efficiency, many of which are in buildings and automation, are all listed here. And we also looked at ways we can shift electricity production away from coal and gas to things like solar and wind, hydro, geothermal, biomass, nuclear, and beyond. We also have to do a few other things, by the way, like improving the grid. We have to have electricity dispatched and stored in new ways to accommodate renewables. And we also have to have more flexibility in how electricity is used. But if we put all these things together, a whole bunch of efficiency solutions, a whole bunch of solutions about producing energy in new ways, and improving the grid, we have an enormous suite of climate solutions right here in electricity. In this picture, each of those solutions is represented by a single circle. The bigger the circle, the bigger the climate solution. Some of those circles actually have two rings, an inner one and an outer one, and that kind of represents a range of estimates we've made about how big that solution could be over the next 30 years or so. So there are a lot of good solutions here in efficiency and making electricity in new ways. Really exciting. Well, let's look at food. Food's also a big emitter of greenhouse gases. Again, about a quarter, 24% of our emissions come from food. A lot of folks, though, think the food emissions come from things like moving food around or food miles you might hear about, or if we grow food maybe organically or with conventional ag or GMOs. We talk about that stuff all the time, but it turns out those aren't the big issues. The really big issues in agriculture emissions for climate change are actually three other things. They're deforestation, kind of burning down forest for new agricultural land. Most of the deforestation on the planet today is happening in Brazil and Indonesia and a few other countries. In Brazil and Indonesia, we're clearing a lot of land for cattle and soybeans that are used to feed animals, mostly in Brazil. So animal agriculture is hugely responsible for deforestation there. In Indonesia, it's mostly for palm oil, being used as a cooking oil, mainly in China and India, but also used as kind of an ingredient in a lot of other foods. The next big area is methane from our animals and a little bit from rice fields. And again, animal agriculture is really important here because cattle and cows burp methane, as we talked about before, and that methane builds up in the atmosphere, causing a big level of new climate change. Basically, we're going to have to rethink meat and dairy products in order to reduce those emissions, either having a lot less of it or growing it in really different ways. Then we have nitrous oxide, that gas I talked about before, which is often produced by using fertilizer too much. Whether that's fertilizer that's chemical fertilizer or manure, they both have nitrogen in them. And if we put too much on a field under certain conditions, that nitrogen can come off into the atmosphere as nitrous oxide, a major greenhouse gas. A lot of the rest, by the way, will run off into the water and cause pollution in streams and watersheds and lakes and even entire oceans. So managing nitrogen and fertilizers is going to be a real big problem, both for climate change, but also for ecosystems and our water. So to solve those problems, we can again look for efficiencies, things we can do to reduce the pressure on the food system. It turns out the biggest place to start is food waste, because we throw away about a third of the food grown on the planet. Food waste is so crazy. In rich countries, we use far too much food and throw away a lot of it, and it's never even eaten, and that's just tragic. In poor countries, though, food waste is often about the same number, but it happens closer to the farmer, because maybe the crop didn't get to the marketplace. Maybe it rotted in storage, or it never got on the truck, or the train broke down. So we lose food there too, and the farmer loses their income. Kind of a double tragedy. So food waste is actually a huge problem, not only for climate change, but food security and a lot of other things. It's a problem worth solving. We also have to think about diets. I showed you how meat and dairy products were responsible for a lot of the big drivers of these emissions. So eating more plants and less meat-based products is a really simple, kind of easy, thing to do. If meat and dairy are responsible for a lot of emissions, let's eat a little less of that stuff and then grow what we do eat better. We also have to protect ecosystems from being cleared. Can we put up big fences and just say no to deforestation, stop them in their tracks, make sure we don't clear forest, and especially forest with peatlands under them that have carbon in the trees but carbon in the peat below ground. But then finally, we can also improve the way we farm on the lands we still are farming. That's going to be a whole bunch of different things about using water better and nutrients better, tilling the soil less, putting on cover crops, all sorts of things. And you'll hear a lot of excitement about regenerative agriculture, which kind of mimics nature's way of doing things as we farm. Regenerative agriculture and these other farming practices can reduce emissions a lot, and that's really crucial. Later, we're going to talk about the potential of some of those farming techniques to not only reduce pollution, but also create new carbon sinks that might absorb CO2 and put it into the soil. That's pretty cool too. But for now, we're just talking about reducing the emissions from farms. Well, let's put all this together. It turns out by looking at all the food solutions, we see food waste is huge. Changing our diets can be huge. Protecting ecosystems, especially forest and forest with peatlands below them, are really important, and farming differently is a major contributor too. So the solutions to the food system climate problem are partly due to us, partly things about ecosystems, and partly what's happening on the farms. We can all do our part here. Well, then let's flip to industry. In industry, we make a whole bunch of things that take high temperature, very intensive processes to make, like metals, especially steel. Steel is a big contributor to climate change. Cement. Making cement releases a lot of CO2 into the atmosphere. Our chemicals, and also plastics, things like that, each make some CO2 as well. By the way, we hear a lot about plastic being a big climate problem. It is. It's about 1.5% of climate change is tied to producing, using, and disposing of all the world's plastic. Definitely a problem, but it's even more of a problem out in the larger environment because it's affecting marine ecosystems and causing pollution all sorts of other places too. And then finally, managing waste. And the gases used in managing waste, but also released from landfills, is crucial. We're going to look at that too. So we're going to look at all sorts of industrial processes, manufacturing and materials, and how we process and manage waste across all of those different domains. At Drawdown, we've looked at a few already and put numbers on them, like what can we do with cement, what can we do with plastics, and then we look at a specific suite of chemicals called refrigerants, which are all these fluorinated gases. It turns out that fluorinated gases like chlorofluorocarbons are very dangerous. Back in the 70s, we realized that chlorofluorocarbons were actually hurting the ozone layer way up in the upper atmosphere. They also contributed to global warming. But we phased out most of those chlorofluorocarbons and replaced them with hydrofluorocarbons, or HFCs. Those don't hurt the ozone layer, thank goodness, but they still contribute to climate change. So they're ozone-friendly but not climate-friendly. We're going to probably have to replace them again and replace them with climate-friendly refrigerants and make sure that none of the existing refrigerants leak and get into the atmosphere. We've also looked at ways we can use waste as a resource. Rather than throwing something away and never using it again, the kind of recycling, repurposing, and actually using energy from our waste streams is a really clever idea, which makes just all sorts of sense. So if we think about improving materials, especially refrigerants, and using waste as a resource, we have a lot of solutions already appearing in the industrial sector. We've got a few more to work on, especially steel and a few other things, but we've got a good start here. Then we got transportation. Transportation is about 14% of the problem. Most of that is on road transportation. 10 of that 14% is in roads, cars, trucks, things like that. The flying we do, aviation, is a little less than 2%. That's all the commercial and military aviation on the planet is about 1.8% of global emissions. Everything else is another 2% or so. That's going to be ships and trains and other things. But mainly it's roads, planes, and the rest. CO2 is made here, that's pretty clear, by burning the fuels we use in transportation. Gasoline, diesel fuel, jet fuel. When we burn these liquid fuels, it releases carbon dioxide into the air. Well, let's take this to everyday life. Like imagine a gallon of gasoline. You pick up a gallon of water, it weighs about 8 pounds. Gasoline's a little bit lighter, call it 7 pounds. If you burn a gallon of gasoline, which is mostly made up of carbon, you add oxygen to it, 2 atoms of oxygen for every one of those carbon atoms, that 7 pounds becomes 20 pounds of pollution. And that 20 pounds of pollution goes into the atmosphere right out of your tailpipe. and goes into the air and stays there for centuries, long after you're dead. Can you imagine that? Just burning 1 gallon of gas releases 20 pounds of pollution that could be up there for 1,000 years, maybe? That's incredible. So it turns out driving the average American car, which gets about 25 miles per gallon, driven about 15,000 miles a year, produces almost 12,000 pounds of CO2 pollution, which will last for centuries. That's about 6 tons of pollution. It's more than your car weighs, is what we put in the sky by a big margin. Fuel efficiency is crucial though. If we go from 25 miles per gallon, which is crazy low, to 50, which is just kind of modest with this day and age, we can actually take that 12,000 pounds and bring it down to something like 5,000 to 6,000 pounds. That's a good step. Planes, again, use about 1.8% of the problem here, and that's caused by just burning aviation fuel in those planes, releasing CO2 as well. But we're getting a little bit more efficient in aviation. Today's planes use about 50 to 60 miles per gallon equivalent for every passenger on the plane. It'd be like driving a hybrid car. But the problem is you're going a lot of distance really fast and you can keep doing it. So when we think about transportation, we can look at efficiency, making the current things more efficient, like fuel efficiency in cars, more efficient airplanes, more efficient trucks, and so on. And we can also look for alternatives to fossil fuel transportation, like walking, bicycling, mass transit, or video conferencing, where you don't have to go anywhere to hear other ideas or meet other people. Those are all really great. And then we can switch from a liquid kind of hydrocarbon fossil fueled vehicle to an electric vehicle. Electric cars are here to stay. They're better. They're going to be cheaper. They're going to be fun and useful and cheaper to operate. We're getting electric trains, of course, electric trucks, and other things. This is really crucial. But putting this all together, efficiency of our current vehicles, shifting to other ways of getting around, and then electrifying our new vehicles, there are a lot of great solutions to transportation. Okay, let's get to buildings. They emit directly about 6% of greenhouse gas emissions. But again, they're affecting electricity, transportation, and other areas as well. But what buildings emit directly within their building envelope are primarily from residential buildings. About 2 to 1 of these emissions are from homes and apartments compared to public and commercial buildings. So we're talking a lot about homes, apartments, as well as big public buildings too. Well, we emit greenhouse gases directly from buildings in our furnaces and boilers and hot water heaters, because they're going to burn natural gas or maybe fuel oil, heating oil, things like that. And those emit CO2 right from your basement. But buildings can also release refrigerants from air conditioners and refrigerators kind of accidentally if there are any leaks in your air conditioning equipment or your refrigerators and your freezers. That's why we always should be tuning those up and watching them. In a typical American home, we actually use a lot of natural gas to heat our spaces, especially in a cold place like Minnesota, where I live, or to heat our hot water for taking showers and things like that. And we measure natural gas in what are called therms. A therm is 100,000 BTUs worth of heat, and that's what your gas meter is measuring it in. The average home in a cold part of America uses about 1,000 therms every year, and that would add up to about 13,000 pounds of CO2, more than your car in a lot of cases. So again, we have to think about electricity and transportation, but also the energy used within our buildings, often as natural gas or heating oil, in order to tackle climate change. So that's why building efficiency matters so much. A lot of buildings are still too inefficient. They leak heat out, they pour heat in during the summer. We can make buildings really much more efficient. We can always build new green buildings, of course, but we're going to have to do a lot to retrofit the hundreds of millions of buildings that already exist. Then we got to shift to new energy sources that don't burn fossil fuels to heat our homes, cool our food, and give us nice hot showers. And we've got to pay special attention to the refrigerants in air conditioners and freezers and refrigerators, because when those leak, they become a kind of super pollutant, causing disproportionate climate change. When we look here, we see energy efficiency, shifting energy resources, and addressing refrigerants are going to be the crucial aspects of buildings in climate change. Let's wrap up here. Now we've got the last sector, which is everything else, the other category, about 10%. A lot of this is from the energy sector itself when they flare off natural gas in an oil well, or what are called fugitive emissions, which are kind of the emissions that escape accidentally from a fracking well of natural gas, or a coal mine, or a leaky natural gas pipeline. These are things we should demand the energy industry address right now. These are super low-hanging fruits that if the energy industry cared at all about this, we could shut off like 6% of climate change today. So what have we learned? We've learned that attacking the sources of greenhouse gases are the first biggest step to addressing climate change. And there are big 5 areas we should be focusing on: electricity, food, industry, transportation, buildings, and so on. And we can see those here. But then inside those major sectors, we have hundreds of little areas that are all really important to address if we want to solve climate change. There's absolutely no silver bullet here. We do a lot of individual things between flying and cement and plastic, electricity and buildings and food and meat and everything else. All of those little things contribute to climate change. So we're going to have to do a lot of little things together to solve climate change. There are many sources, therefore there are many solutions. We're not going to solve climate change simply with a solar panel, or by eating less meat, or not flying, or not using cement. We've got to do a little bit of all of that stuff. And usually, one of the repeating lessons we saw here is start with efficiency. Wasting less energy, wasting less material, wasting less food. Those are all really crucial. And then switching what we do to something that doesn't emit greenhouse gases. We can still make electricity, but do it differently. We can eat food that doesn't emit greenhouse gases. We can make stuff and live in places and get around without any fossil fuels at all. So between efficiency, where we usually start, and transforming the economy to a low carbon economy, we have some great solutions to tackle climate change.
All right, I hope everyone enjoyed that. There was a lot of really good information there. I didn't do much of an introduction on Drawdown itself. It's an international organization that's based in San Francisco. Who you saw there was its executive director, Dr. Jonathan Foley. And as he mentioned, he lives in Minnesota. He was the director of the Institute on the Environment at the University of Minnesota for a number of years, and then took this job as the executive director at Project Drawdown, I think in 2019. And he does a lot of these. He writes a lot as well, and very good person to follow on Twitter. If you don't follow him on Twitter, has lots of great insight. He's very pragmatic about his approach to reducing carbon sources. And I want to point out a couple of things that we saw there. Knowing this is an international organization, so the pie chart you saw was global. If you're used to seeing the US pie chart, it has transportation a lot larger. That's our largest sector in the US at about 27-28%. That's because Americans drive and fly a lot more than the rest of the world. And we drive gas guzzling single passenger vehicles to and from work. Not all of us, of course, but in general, that's a huge contributor to the US carbon emissions. Pretty clear there also, electricity needs to be our #1 priority, because a lot of the other solutions depend on low carbon electricity in order to transition to a clean energy economy. As we transition to electric cars, as we transition away from gas burning furnaces and water heaters, we're going to transition to electricity. And if we have clean electricity, that will make a huge, huge difference. Also, the building sector at 6% of emissions is smaller globally than it is in Minnesota, because we use a lot of natural gas to heat our homes, and also for water heating and our gas dryers and cooking as well. So that's a bigger segment in Minnesota. It's about the same for US. And one more thing I'll point out there, the other category, the one that he didn't have any, he talked about a lot of it is in the petrochemical and energy sector. The thing that gives me optimism about that is as we transition away from the use of fossil fuels, that sector just disappears without replacing it. It's going to be, instead of all this methane leakage and all this off-gassing from oil refineries, we're just going to have there will be some emissions from making of solar panels and wind turbines, but all of that leakage that is in that other category just disappears. So that's a big chunk that just goes away as we do all the other things immediately. There were a couple of comments, and I will, if you do have any comments or questions, write them in the chat, or just say I have a question in the chat. And make sure, if you want everybody to see your question, make sure you designate that everyone can see it. And the one comment I got, I'll go ahead and read that. Just a reminder to participants, we need to elect people who will support climate change solutions and legislation, get involved with local elections, support candidates who are climate champions. It can make a difference. And those are very true words. We just saw the passage of the climate and bill in the state last night, late last night it got passed, which was great news, as well as they are going to go ahead with the clean cars standard, which was really good news. And so all of that we need to keep our eye on, because these things, and Jonathan Foley will say this many times, at the local level is where these carbon emission reductions are taking place. Local governments, municipalities, states have made great progress. And I just heard him say on a live thing yesterday that if you're waiting for US Congress to do something, you may be waiting a long time. But that's his opinion anyway. So any other questions before we move on to the next unit? All right, we will move on then. See if I can navigate this. I couldn't get that to go off of full screen for some reason. Well, here it is right there, supporting sinks. So this, we get a.
On March 16th, 2021, 6 women were among the victims of a horrific.
Oh, we're on YouTube now. No, this is the right thing. We're just going to go.
Okay, so now we're going to talk about how we can address climate change by looking at the sinks of greenhouse gases, and also how changes in society can have secondary benefits to climate change. As we think about these issues, one of the best places to begin is supporting nature's carbon cycle. These are things that are naturally sinks of greenhouse gases today. If we zoom in here, we can see how forests and oceans are absorbing over 40% of the pollution we put in the atmosphere every year, most of that in the form of CO2. And so if we can support those sinks and make sure they stay healthy, that would help us address climate change into the future. But the problem is some of these systems aren't that healthy right now. A lot of our forests are feeling the weight of climate change already, or are being torn down. And our oceans are getting warmer and more acidic, and they're also getting more polluted and over-harvested at the same time. So job number one here is just kind of support nature, give it some backup, and make sure that it isn't diminishing these sinks we already have. Later, hopefully we can augment those sinks by putting other land and other ocean systems into production and add to what nature's doing already. But here's the math we got to start with. 100% of these emissions are coming from us. Land is putting out about 24% or removing it and putting it into our forest. The oceans are pulling out about 17% of the greenhouse gases and putting it into different parts of the ocean. Interestingly, even though oceans cover a lot more of the Earth's surface, they actually take up less of the carbon than land does. Oceans are important, but forests are kind of a big story here. Altogether, that still leaves about 59% of the greenhouse gases in the atmosphere. And so this is part of the solution, but it can't be the whole solution. And before we look at the individual sinks, there are about 4 major points I think we have to talk about before we even get started. First of all, it is crucial that we give nature support because nature is already doing 40% of all the removal, and we're doing zip. So starting with backing up nature, giving it support, and making sure we don't lose that service of removing greenhouse gases is crucial. Then once we kind of get that stuff secured, we can also maybe add some of our own new carbon sinks, like planting new trees or farming new areas in different ways, or maybe machines that pull carbon out of the atmosphere, all of that. But first, why don't we help out nature that's doing a good job already? The second thing to remember is sinks all have limits. They can't take an infinite amount of greenhouse gas out of the atmosphere. There's no way. Trees only get so big. Soils only go so deep and can have so much carbon in them. Coral reefs can only grow so fast. So we have things that have a limited capacity to absorb our greenhouse gases. That's why it's probably more important to stop them before they ever get in the atmosphere than try to remove them later. And that leads to a third point. Sinks take time to absorb greenhouse gases. If you put out a ton of CO2 today and plant trees to offset that, it might take 100 years for those trees to grow fully to maturity, absorbing carbon out of the atmosphere. But in the meantime, you've got 100 years of climate change caused by the pollution you started with. So you can't really get away with this. By planting trees to offset emissions introduces a time lag where climate change is just going to be worse. There's kind of an asymmetry here. Turning off a power plant stops pollution today. Planting trees or building coral reefs or whatever basically is a solution for 50 to 100 years from now. The other thing we have to worry about is sinks may not always be permanent. They might not be secure. For example, some of our sinks are biological in nature, growing a new tree, putting stuff in the soil, putting stuff in a kelp forest or whatever. Those are biological sinks and they're great, but they can also be reversed. We can plant trees and then they can be burned down. We could farm really well and build up the soil, but that farmer retires, the next one comes in and plows it all up and it goes back in the atmosphere instantly. So these kind of biological sinks can sometimes be quite ephemeral. They may not be permanent, but some sinks might be more geological in nature. If we can lock up carbon in kind of like a rock or something like a coral reef or down in the basalt or something like that, then we got something that's locked up pretty much permanently, at least on human timescales. So let's look at these sinks one by one. On land, again, it takes up about 1/4 of our emissions, which is pretty amazing. And it's doing it with photosynthesis. The natural vegetation of our planet, especially trees, are growing a little bit faster now, and they're accumulating more biomass, or essentially wood. And when those things die, they build up a little more carbon in the soil, what we call soil organic matter. So photosynthesis, biomass of the living stuff, and soil organic matter, that's where all the carbon goes. And we can help maintain those sinks in nature by leaving nature alone. We can first take pressure off of nature by not clearing forest, for example. And that's where food waste and diets and things like that, where we don't need to grow more food and invade those forests because we're more efficient with the food we already grow. That'll be crucial. But also putting up kind of big protections around the remaining rainforest and peatland forest and other ecosystems to make sure they're never cleared at all. And then once we've kind of taken care of nature and secured it, then we can do exciting things like putting our farmland into new types of agriculture that might absorb carbon, what we often call regenerative agriculture. So we looked at these solutions. We looked at food waste and diets, not by just reducing emissions, but preserving sinks. We looked at how protecting forests didn't just reduce the deforestation emissions, it kept the forest sinks intact too. And then we looked at how changing agriculture and degrading lands back into production and reversing that can be really important as well. One of the things I want to mention, though, is regenerative agriculture is getting a lot of attention these days. This idea that farms and ranches can be farmed differently to absorb carbon. That is true. There's a lot of great evidence showing that we can grow crops and livestock in ways that can actually absorb carbon, whether in trees in the forested areas around the farmland or in agroforestry or in the soil itself. And that's really exciting. But there are limits to how much this can happen. There's only much soil you can build up. There are only so many trees you can build up, and they are all kind of temporary. The next farmer or a drought or a fire could disturb all of them, putting them back in the atmosphere. So be careful there. There's also a few groups that are not really paying attention to the science, I would say, that are making big, bold claims that regenerative agriculture can absorb all of our greenhouse gas pollution. That is just not true at all. The scientific community is quite clear that it is a solution, but it's one of many solutions, and we've got to make sure we balance it with all the others. So when we look at the numbers, we see that protecting ecosystems and reducing food waste, kind of protecting and taking the pressure off of ecosystems, is critical here to preserving sinks. And then we can put the farmlands and the degraded lands into better systems of agriculture so they absorb carbon too. So this combination of kind of taking pressure off of land, protecting it, and then farming our working lands in different ways can be powerful ways to maintain and enhance land-based carbon sinks. The oceans are kind of different. We don't manage the oceans as much as we might on land. A lot of it's out in the open ocean where we don't do so much. Coastal oceans are another matter, though. But either way, oceans as a whole, even though they take 71% of the planet, absorb 17% of our greenhouse gas emissions. And they do it through three major mechanisms. One is what we call a solubility pump. That's just a fancy way of saying CO2 dissolves in water. And what's interesting here is that salt water dissolves CO2 just like fresh water does. But as water warms up, it absorbs a little less CO2 than cold water. So as the climate changes, we can't really expect the solubility pump to get bigger. It's probably going to stay where it is or maybe go down a little. Then we have something called the carbonate pump, which is where living animals pull carbon dioxide and calcium out of the seawater, and they use it to build a shell. Our shellfish, things like oysters and clams and mussels, but also crabs and lobsters. They pull that stuff out of the water and build shells that stay there for quite a long time. Corals are the same thing too. Remember, corals are animals. They're not plants, they're not rocks. They're little polyp animals that build a calcium carbonate shell around them that we call a coral reef. And that takes CO2 out of the water as well. And then we finally have the biological pump, which is just basically the plants of the ocean. The little tiny microscopic phytoplankton and diatoms that do photosynthesis, as well as what we call macrophytes, or big plants, like kelp forest. They do photosynthesis, they build bigger plants, and those plants will later die and get buried in the ocean's sediment. So all of those things, whether it's just chemistry, building shells, or growing plants, pull carbon out of the air, through the water, and tuck it away. We can do a little bit to help already, obviously. For example, protecting the coastal ecosystems from being developed or torn apart, like mangroves and wetlands and marshes are critical carbon sinks. But also, they turn out to be really helpful in protecting our storm surges on the coastline. When we have healthy mangroves and coral reefs and marshlands and wetlands along the coast, we don't have as much flooding or as much damage from storms. So it kind of helps us prevent climate change, but also adapt the climate changes already here. That's a good win-win in my book. But we might also be able to add new carbon sinks out in the ocean, maybe through farming kelp in big regenerative aquaculture systems, or maybe planting new coral reefs and oyster beds and lots of other things. We're just beginning to explore the possibilities here, and I think they're going to be really cool. So we looked at land and oceans, but then we can look to machines to maybe become carbon sinks. There are machines out there, kind of in laboratory settings and a few very small pilots. The atmosphere is not noticing these things at all yet. They're way too small. But the idea here is maybe we could build machines that would pull carbon out of the atmosphere and either store it down in the rocks somewhere or tuck it away and lock it up, or use it for something. That's the one that gets me really excited. If we could pull carbon out of the atmosphere as carbon dioxide or whatever, and use it to make plastics or jet fuel or other things society might want without using oil at all. Use pollution to make our stuff, not new oil. Leave the oil in the ground, we'll take the old stuff out of the air. That would be really cool. This is nowhere near being deployable right now, but some of these technologies are very interesting. And over the next 10 years or so, I think we're going to see a lot more rapid development of these technologies, and they may start to play an important role. So we've looked at the carbon sinks, and before that, the carbon sources. And we can see by reducing pollution, working with nature, and maybe augmenting nature, we've got a lot we can do about climate change. But there's a third principle too, that improving society, not because of climate change, but because it's the right and moral thing to do, turns out to be a great set of climate solutions. It's kind of interesting. And turns out improving equality and equity, especially with women and girls, for example, improving the access to education and healthcare helps women and girls see new opportunities around the world. And as a consequence, women and girls will have maybe fewer children, but healthier children a little bit later in life than they might have otherwise had. And when that's the case, the growth of population in the future might bend down earlier than we thought before. While population growth actually isn't really responsible for most of climate change, most of the emissions are from rich people, not poor people. Future population growth slowing down will actually help us a little bit in the long run as population growth and economic development drive up emissions in the future. So this is a great win-win. By helping women have new opportunities, we might actually help the environment and the climate as well. So it turns out that helping people, for lots of good reasons, actually can help us with climate change as well. And this represents kind of a win-win opportunity to improve human well-being as well as improving our future climate solutions.
Okay, that was interesting. I'm sure if you were not familiar with some of Drawdown's solutions before tonight, the last section may have been a little surprising to some, as the talking about educating women and girls and gender equity as being two of the solutions to climate, which when I first read the book Drawdown a number of years ago, that was surprising to me that that it was such a big part of it. Which is great. It's great to see an approach where, you hear some people say, we need to have population control in order to have a climate solution, and that's not it. That's really not the route that Drawdown talks about or international organizations talk about. Helping people, giving aid, education, healthcare is really a great solution there. And as Jonathan Foley points out, it not only helps the people there, live better lives, it helps them, manage carbon emissions, make better choices on, the energy they use, the food they eat, and so forth. So that was really interesting. Another thing I'll point out from that one, he gives a much more positive spin on the engineered sinks in this vignette than he has. I was in this live forum with him yesterday where he really was, saying that these engineered sinks, we need to increase our current amount by about 1 million times to do a fraction of a % of our carbon emissions. And one of the drawbacks, one of the traps that we're getting into is a lot of companies, industries that are making net zero pledges for 2040 or 2050 or whatever, are basing them on, not cutting their emissions today, but rather pledging that they'll take carbon back out of the atmosphere in 30 years with technology that really hasn't been invented yet, and relying on some of these prototypes, these lab scale things, and saying, this is going to be taking carbon out of our atmosphere using mechanical and chemical means 30 years from now. And it really is not a feasible, the amount of machinery they need to build in order to take the carbon out of our atmosphere is just, it's just unbelievable how much they would have to do there. So that's something that we really shouldn't be relying on. And you'll notice in both the first and the second one that trying to maintain the sinks we have now, the temperate forests, the tropical forests, the mangroves, the peat forests, is really should be our highest priority. And we're not doing a very good job of that right now. So those are things that we need to do. And also, when we talk about food waste is so big, and it seems like low-hanging fruit there as well. All right, I didn't get any question. I think if you do have any questions, make sure you put them in the chat. Does anybody have any questions or comments before we go to the last one? Lori?
Is the chat working? I tried to put something in the chat and it wouldn't let me enter it. I don't know if the chat's working.
Yeah, I'm having something similar. I can't send it to everyone. I can just send it to the host or co-host.
Oh, okay.
And then I wasn't able to even save that one. So I don't think it's working.
Okay. Does anybody have a question or a comment?
I just had a question about, it's enthusiasm for plastic, like taking carbon out and, making more plastic. I think plastic is a huge problem for many different reasons. And I think we should look at reducing plastic and not thinking of different ways to make it.
Yeah, agree. Any other comments or questions? So this last one is, I think, 13 minutes, so we'll be going a little bit over an hour. And then if you have any questions at the end, we'll try to keep it to an hour and 15 minutes at the most. Let's see if I can get back to my Drawdown site instead of doing it on YouTube this time. Let's go here, and I may have to do a little shuffling around here. Go away. Where's my Drawdown? There it is. Here's Drawdown. And where is here? I just need to go back. And here we go. Now I'm back on the Drawdown site. So making it happen. Okay. And we'll go and we'll make it.
Okay, so in this final unit, we're going to talk about how we can make this all happen. We've got solutions, but now we've got to put them out into the world. We've learned a lot along the way, though. First of all, it is not too late to stop climate change, not at all. We have enough solutions right at our fingertips to solve the problem. We simply have to put them out into the world. And remember, these solutions are good for us. They're going to make the world better. Analogy I kind of like to use is you go to the doctor, you learn you're kind of sick, and you might learn about a treatment, but there are side effects, it's going to be kind of nasty and things you don't really want to do. This is kind of different. We go to the doctor and learn, hey, we got a real problem, but the solutions are going to actually make you healthier, happier, richer, and better off in the long run. Why not? Why the hell aren't we doing this? Well, the first thing we have to remember when we move forward to actually implementing these solutions is time is the most important variable. We've been wasting decades talking about climate change, but not doing enough to stop it. If we take the solutions we have now, let's not wait for any more technology or anything else. We start today, we can still beat climate change. But if we wait because of politics, we wait because of obstructionism, we wait because we're waiting for the perfect new technology, we are going to lose. So we have to start now. We need time, not tech and talk. That's what we need. And in Drawdown, we have a saying, now is better than new. We've got to get going with what we have today. So how do we deploy these solutions? How do we take them out into the world? The solutions are, again, kind of physical things. They're a technology, a practice that actually affect the atmosphere. They're things we need to have more of quickly. How do we make sure they get there? Well, we have things we call accelerators, things that move solutions into action. And they include a lot of different things. For example, we got to change the rules, effectively changing policy, like the laws we have or regulations or how we collect taxes and what do we tax, what do we incentivize, all of that kind of policy making. Whether it's in Washington or at a federal capital or at a state level or at a city level, all of those policies are really, really important and can help us take solutions to scale more quickly. But we've also got to work with money and capital and investors and all this kind of stuff. We got to pull capital out of the things destroying the planet, oil and gas and all that kind of thing, and out of bad forms of agriculture and destructive industries, and move capital into good things that are actually promoting climate solutions and maybe a regenerative economy, one that makes the world better. We've also got to reform the way businesses think about these things. We need to look beyond just right in front of our nose at quarterly profits. We've got to look at the long view, which knows that businesses have to take on climate change too. It's a really terrible business environment if the planet's going haywire. So if businesses take a longer perspective, they can actually incorporate climate solutions and better thinking into their daily practices. And businesses could be very helpful, but right now, largely they're not. We also do need more technology, partly to take what we already know how to do and make it cheaper and faster and move at scale quickly, as well as some fundamentally new things. But we can't wait for technology, we'll just fold it in as we go. So that'll be really important. And we do need behavior change. We absolutely do. You and I, at our household levels, at our communities, our schools, our places of worship, all of these places, we can make little changes that do add up. They're not enough to solve the problem, but without behavior change, things like how we eat, food waste, our energy conservation strategies, do require that as individuals and communities, we play sort of a role as well. So we need it all. Just like climate solutions, we need a lot of accelerators as well, from the policy making to individual behavior to moving money, inventing new things, and changing the rules of business. We need everything. But how's this going to play out over time? Well, we're going to be addressing climate change for a while now. It took us a good 100 years to get into this mess. It's going to take a couple of decades to get out of it. It's just inevitable. So I think about climate solutions unfolding over, let's say, the next 3 decades. We got the 2020s to work on it, the 2030s, and the 2040s. How do we play it out over time? It's kind of like a big chess game. We now know all the pieces on the board. What are our opening moves, and what are the closing moves we need to win the game? Well, I think there will be kind of 3 waves of action that all begin today, but they unfold a little differently over time. The first wave of action might be, let's deploy the really cost-effective, low-hanging fruit, things we know how to do right now that save us money and are big wins today, and do them fast. Energy efficiency. It's crazy that we still have buildings that leak out half of the energy we pour into them. The fact that we throw away about 1/3 of the food in the world, that we still deforest beautiful tropical forests to grow a few more cows and soybeans. These are all things we can totally fix today if we put our minds to it. There's no reason we should be doing these things. Similarly, we need to demand the energy industry really tackle methane leaks. We're going to move off of natural gas completely. That'll take more time. But immediately, we can stop the leaks in natural gas pipelines, in natural gas wells, and flaring of oil rigs. Those are things we could stop today if we simply regulated that better. And we can also switch to renewables a lot faster than a lot of people thought. Even 5 years ago, I might not have said this, but today, renewables have gotten so cheap, they're now by far the cheapest source of electricity on the planet today. And if we can electrify our cars and our buildings more, they become a solution not only to electricity, but to the building and transportation emissions as well. Solar panels in particular have fallen in price so quickly, it's almost like computers. They're getting cheaper and faster and better, like everything. So iPhones and solar panels have that in common. And the cost of solar cells are so cheap now that solar and wind are now the cheapest ways to make electricity on the planet. This here shows a picture of how much money it costs to build 1 megawatt hour worth of electricity production. Solar and wind are now cheaper than basically gas could ever be, certainly cheaper than coal, and way cheaper than nuclear power. And they're falling in price every day. That's incredible. So there are a lot of things we could do right now very quickly that could have a big impact. Then the second wave, which we also start today, we're not waiting, But this one will take a little bit longer because it's about changing big infrastructure. We're going to have to reinvent a lot of our big systems, whether it's agriculture. We have hundreds of millions of farms across the planet. We're going to have to change them all, one by one by one. And we're going to have to do new kinds of farming that have fewer emissions, or farms that maybe even absorb some carbon dioxide as well. We've also got to retrofit almost all of the world's buildings. Sure, we can build new, like net zero buildings and green buildings and all that. That's great. But most of the buildings we'll see in the first half of the 21st century have already been built. And we've got hundreds of millions of those where we're going to tear out a furnace and a boiler and a hot water heater, put in a heat pump and insulation and building automation systems and solar panels. That's going to create hundreds of millions of jobs and new opportunities. And these are jobs that can't be taken away by AI or robotics, and they can't be shipped overseas. This is a great opportunity for economic development too. We're going to do the same thing with transportation. Every car, every airplane, every truck, everything has to be retired and fast and replaced with more efficient and hopefully electrified vehicles that can emit no pollution but still give us great mobility and even better transportation than we see today. And of course, over the same time period, we can deploy new technologies, but don't wait for them. But we will have to invent a few things along the way that can make things cheaper and faster and better, but also whole new ways of doing things. For example, in industry, we still are going to have to tackle the problems around cement. There's some interesting prototypes for this, but we've got a long way to go. We're going to have to find new replacements for refrigerants, away from these fluorinated gases like hydrofluorocarbons to ones that aren't super pollutants in climate change. And we also have to do things like making steel in ways that don't emit high amounts of carbon dioxide. These are all possible, but we got a little ways to go for that. Then we have things that I think are going to be pretty exciting, like how do we make jet fuel out of the air instead of out of oil? How do we have a drop-in replacement for aviation so we don't contribute to climate change when we fly? Or making air turn into plastics, so we're not using oil to make things we might need. We're actually using last year's pollution. These are all ideas that need a little more work and can be deployed over the next few decades. But what you see here is climate change is, yes, a huge problem, but I actually look at it a little differently and see it as a great opportunity to kind of reboot the planet. We have to reimagine everything, the way we make our energy systems work, electricity, transportation, buildings, the way we grow food and use what we grow and ship it around the world and what we eat and how we eat it, all of that. Everything has to be reinvented. That's great. That's an opportunity to rethink everything. As we fix our problems around climate change, we could also have an eye towards equity and justice, and maybe address some of our long-standing historical dilemmas there. We also could look for opportunities to grow new jobs as globalization has wiped out other jobs. We could also create healthier cities where people walk more, get more exercise, lead better lives, breathing cleaner air, and addressing some of our biggest public health concerns. So to me, addressing climate change isn't a bad thing. It's one of the biggest opportunities to build an incredible world we've ever seen. So what else do we need? I'm convinced we actually have the solutions and technologies at our fingertips to get going and solve this problem. We also know how to push them out into the world with policy, behavior, capital, and so on. But we're missing something. One of the things I think we're missing right now is a much better and bolder vision of leadership. We don't have that today, sadly, in most places. Today, a lot of our leaders are saying the future is going to be terrible. It's going to be dark, dismal, dystopian futures, and those people are to blame for it. We're causing people to be fearful and divisive and hate each other. We are now more divided in the United States, for example, than any time since the Civil War. And I don't even know why. We have to move away from that model of leadership if we want to be the best version of ourselves and solve one of our greatest civilization's problems. So what we need is a different kind of leadership that paints a picture of the future that we can join together in and build a better world. Martin Luther King, for example, didn't go around America saying, "I have a nightmare." He talked about a dream that even those who didn't agree with it at first knew in their bones was right and true and moral and just. He had a dream where measuring people on their character, not the color of their skin. And that dream was beautiful, and he invited all of us to join in and make that a reality. Now, he died for that dream, and we're still far from achieving it completely, but we're on that path, slowly but surely. What about climate change? What if we said to the world, solving climate change is one of the best ways to make a better world? And we invite all of you, conservatives, liberals, big city folks, small town people, to come together and build that better world. I think it would energize millions of people and bring together us around one of the greatest achievements we could ever have. So my ask of you is for you to step up and be a leader in your life, in your community. There are always people who look up to you, who ask you for help, and you have influence across your businesses where you work, your communities of faith, your schools, your neighborhoods. All of us can share and learn what we know and lead all of us into making a better world, one bit at a time. I hope at Project Drawdown we can be a resource to you along your leadership journey. Come to drawdown.org. We're going to have lots of resources about climate solutions and hopefully network people together so we can work together to build this bigger planet and solve these bigger problems. But we ask you to exercise your leadership. Don't abdicate your future. Don't abdicate your responsibility, and don't abdicate your leadership in making a better world. And remember I started this whole thing in saying the future is not written yet. Robert Henton Wilson once said the future is up for grabs, and it belongs to the people who accept the risk and the responsibility of consciously creating the future we want. So let's go out and build a future by design, a better future, not one by default. And that future is up to you and up to me and all of us. And I think we can make it a great one.
Okay, it's nice for him to land on such a positive note. He's very optimistic. Well, I don't know if he's really that optimistic, but he really has a very positive message for what we can do if we can get it done, right? So it was very good. I had one more question, and again, the chat thing is only working to send messages to me and Lincoln. And for those of you who joined late, if you see two Lincoln Fletchers, Fetchers. I'm Steve Jorson. Lincoln is in the other screen. But so we're getting your messages, and from Kelsey, it says he mentions protecting peatland forests, and there's a lot of peatland up around the boundary waters, which is yet another reason why it's important to prevent mining up there, which is a great point. Preserving the boundary waters is a very high priority, and it's great we have our own Betty McCullum, who's our U.S. representative here, is a big champion of the boundary waters, and she's talks about that a lot as well. So great point, Kelsey. Any other questions from anybody before we close up tonight? I encourage you to watch units 1, 2, and 5. They're also very good, and follow Jonathan Foley and Drawdown on the Facebook Drawdown is not. I don't think it's part of Project Drawdown. I'm on that. There's a lot of stuff that comes through there that doesn't really look like this. But if you follow Jonathan Foley, his Twitter handle is Global Eco Guy, which is kind of funny. I also put our website in the chat. NortheastMetroClimateAction.org is there if anybody wants to log on to our website, and then also follow us on Facebook if you don't already. We're very happy to have followers and friends on Facebook, where we post a lot of good information about upcoming events, both within Northeast Metro Climate Action and other events around the Twin Cities and of concern to the climate. All right, with that, We will say good night, everyone, and thanks for joining us. And we'll put this recording on our Facebook page if you want to watch it again, or steer your friends to it because you liked it so much. All right. Good night, everybody.